Good day, everyone. Today, we'll explore one of the most important concepts in meteorology solar radiation and Earth's energy balance. Have you ever wondered why Earth is warm enough to support life, or why temperatures vary between day and night? The answer lies in the energy our planet receives from the sun and the energy it sends back into space. In this video, we'll discover how solar radiation powers Earth's weather and climate through Earth's energy balance. Before we dive into our discussion, let's first look at our learning objectives. By the end of this presentation, you should be able to explain solar radiation and its forms, describe how solar energy interacts with Earth, explain Earth's energy balance, and relate it to weather forecasting and climate change. Let's begin with solar radiation. Solar radiation is the energy emitted by the sun in the form of electromagnetic waves. It is Earth's primary source of energy and the driving force behind many atmospheric processes. The sun emits different kinds of electromagnetic radiation, but the three most important reaching Earth are first is ultraviolet radiation, which carries high energy and is responsible for sunburns and vitamin D production. Second is visible light, which allows us to see and provides most of the light reaching Earth's surface. And third is infrared radiation, which is associated with heat and plays an important role in warming our planet. Without solar radiation, Earth would be too cold to support life. It powers photosynthesis, drives the water cycle, influences wind patterns, and provides the energy needed for weather systems to develop. Now let's follow the journey of solar radiation after it reaches the Earth. When sunlight arrives at our planet, it does not all remain here. Instead, incoming solar radiation has two immediate outcomes. It is either reflected back into space or absorbed by Earth's atmosphere and surface. So the first outcome is reflection. Approximately 30% of incoming solar radiation is reflected back into space by clouds, atmospheric particles, bright surfaces such as snow and ice. This reflectivity is called albedo. Surfaces with a high albedo reflect a larger portion of incoming sunlight, while darker surfaces such as forest and ocean absorb more solar energy. The remaining 70% of incoming solar radiation is absorbed by Earth's surface and atmosphere. The oceans, land, vegetation, and atmospheric gases absorb this energy, causing the planet to warm. This absorbed solar energy drives important meteorological processes including evaporation, atmospheric circulation, cloud formation, and the water cycle. As Earth's surface warms, it does not store this energy indefinitely. Instead, it continuously emits the absorbed energy back toward the atmosphere and space as infrared radiation, also known as long-wave radiation. This outgoing long-wave radiation is a key part of Earth's energy balance because it helps regulate the planet's temperature. Now that we've seen how solar energy travels through Earth's system, an important question remains. If Earth constantly receives energy from the sun and also releases energy back into space, why doesn't our planet continue heating up or cooling down indefinitely? To answer that question, let's examine how Earth maintains its energy balance.
Balance refers to the relationship between the energy Earth receives from the sun and the energy it radiates back into space. And the amount of incoming shortwave solar radiation equals the amount of outgoing long-wave infrared radiation. The Earth's average temperature remains relatively stable. If the Earth absorbs more energy than it releases, global temperatures increase. So if the Earth releases more energy than it absorbs, temperatures decrease. Maintaining this balance is essential because it regulates Earth's climate, and influences weather patterns around the world. Important part of Earth's energy balance is the greenhouse effect. Imagine wrapping yourself in a blanket on a cold night. The blanket doesn't create heat. It simply traps the some of your body's warmth. Earth atmospheres work in much the same way. Greenhouse gases, including the water vapor, carbon dioxide, trap part of the outgoing infrared radiation and prevent all of it from escaping into space. Natural greenhouse effect keeps Earth's average temperature at about 15 degrees Celsius. Without it, Earth's average temperature would be around negative 18 degrees Celsius, making life as we know it impossible. Understanding solar radiation and Earth energy balance has many real-world applications. Meteorologists use these principles to improve weather forecasts and climate models. Here in the Philippines, agencies such as the Pag-asa monitor solar energy, atmospheric conditions, and climate patterns to provide weather forecasts and issue early warnings that help protect lives and property. By understanding solar radiation and Earth energy balance, we gain a deeper appreciation of how our planet works and why protecting its climate is everyone's responsibility. Thank you for watching. Bye-bye!